Wheat is very important. It's one of the staple crops in Ethiopia, and then the local production is not good enough to satisfy the demand. So every year, the government spends millions of dollars to import wheat to just meet the local demand. Marple diagnostics will be very important because recently the government adopted a policy to be self-sufficient in wheat production. So we are going to produce wheat 2 or 3 times per year. We need to look out for the disease like yellow rust, and having this kit to monitor the disease trends or progression will be key so that we can have enough amount of production every year. So it will be critical to achieve food security in Ethiopia.
The Marple project really started as a result of the work that Diane Saunders had done at John Innes around field pathogenomics. And then based on that, there was the opportunity to make it a rapid mobile diagnostics system using the nanopore MinION sequencing. So this just looked like an absolute perfect opportunity to integrate with the wheat rust monitoring system that we already had running.
We wanted to make something that was a bit more portable to open up the chance of doing genomics-based genotyping of rust strains to all around the community. And so we then decided to move our methodology over to the MinION sequencing platform. And so that's how Marple Diagnostics started. And it was really initiated through the want to make this more accessible to everybody, irrespective of access to resources.
Ethiopia was really the perfect place to start Marple. So Ethiopia is the biggest wheat producer in sub-Saharan Africa, but it's also really a gateway for wheat rust races that are either coming into East Africa or moving out of East Africa. So the geographical location and the importance of wheat are really key.
Having Marple Diagnostics up and running in Ethiopia will allow us to quickly identify any new strains of the wheat yellow rust pathogen that enter the region. And so these might be exotic incursions where you get completely new strains moving into the country. And in those cases, it's quite devastating the impact that they can have because, of course, they might be able to grow on wheat varieties that were previously resistant.
COVID has had a big impact. It just wasn't safe to bring large group of people together. We really had to put Marple, I think, on hold for almost a year.
One great thing that has come out of COVID is we're all much more aware of the capabilities of using virtual tools, and we have been able to move all of our training online and then use online systems to make sure that people are still skilled up, even through the difficulties that the COVID pandemic has presented to us. The aim of the virtual workshop is to provide people with skills in Marple Diagnostics to be able to utilize this method at the specific 5 Marple hubs that we've developed in country to host the Marple Diagnostics method. On the side, we also want to provide people with basic training in molecular biology and also bioinformatics, which is a difficult area to get good training, especially in countries in East Africa. And also how to utilize all the possibilities that are presented through the use of the MinION portable sequencer developed by Oxford Nanopore here in the UK, and how they can use that sequencer not just in the Marple Diagnostics project, but also in other projects that they might have in their labs.
I get a lot of knowledge on practicing this pathogen identification, which will help me for the future working. We have no sequence machine in our lab. We are sending it to Nairobi and other places.
I have advanced myself on the techniques in molecular biology more, and also on the bioinformatics parts also. With this technology, I think it will be a good opportunity for us.
Certainly, there are benefits, I think, for the future that we've clearly shown that this is possible. You can do a very advanced technical workshop and do it remotely. The expected outcome from the workshop is that the participants, they would basically have all the knowledge and skills that they would need to then go back to their respective institutions and to be able to set up the Marple pipeline and to be able to run samples through it. So that's what we hope is going to happen as a result of the workshop that was just run.
So the next steps following the workshop is we really want to see Marple diagnostics working in people's hands outside of the workshop setting. And so we've provided extra consumables and so on so that people can also process a few samples this summer, following on from the workshop and the skills that they've learned.
We know we've got a new race of yellow rust that's come into Ethiopia, and we're really worried about that new race. So the idea would be that we get those samples and we really see, is it this new race and how widespread is it? And that has then big implications for the level of urgency and the control that's going to be needed in the country.
We also would like to expand the method to include other wheat rust pathogens and indeed other complex fungal pathogens that are really important for agriculture. So we hope that other people and us will be able to use the same approach to develop similar Marple diagnostics methods for other important fungal pathogens.
And the expansion to other regions. So there's huge interest in other regions to have Marple in place. So I think South Asia would be the next target in terms of regions. So we've already started the early warning forecasting system in South Asia. So now we would really like to try and link Marple into those activities as well. The Marple project, really, it's just been a great partnership, bringing together the best science, but then actually putting it to work where it's most needed.